Good afternoon, everyone. I'm Yijie. I am doing research on point cloud processing and mainly for the building exterior at the urban level, urban scale. So today's talk may not directly connect to the construction field, but I really hope this interesting topic may bring some fun to you and inspire the further application in the field. So this is a simple variant of the Parthenon temple. So what if this could move? Like lean forward, lean backward, and then press up, and then twist its body to look around. Press up, still press up, okay. And twist its body to look around. Oops. And then, okay, so I think you may get my idea. And how could this building could be dense? Because we equip the building with skeletons like this. So we can tilt the joint and move this leg. No, it's the pillars. Okay. So why we want the buildings to dancing with skeleton? People may not familiar with the dancing buildings, but you may be very familiar with dancing human bodies, human animal bodies, and dancing toys. They are controlled by skeletons. So in the field of computer graphics and applied mathematics, shape skeleton is actually a very important concept to do the shape analysis task. The shape skeletonization could facilitate the 3D reconstruction, 3D simplification, abstraction, and then identify the patterns and clustering the patterns, and then even for the following application of prototyping and editing. So this comes to the next question, how to equip buildings with skeletons. Traditional shape skeletons are defined for general shapes, which are very different from the architecture building shapes. They may have very lengthy fragments with complex curves, like these right-hand side figures. And how could we define a skeleton to reflect the symmetry, repetition, parallelism, and orthogonality and hierarchy of buildings? So we propose skeletons for buildings. And you may see in this slide that the skeletons look like a set of building sections. So we name it as a building section skeleton. Our building section skeleton are defined from the atom level to segment level to topology and patterns level, which could be represented by graphs with nodes and edges to represent the important components of buildings and their connections. So as a comparison, you can see in this part, the BSS in 2D is much shorter and more consistent with the human perceived symmetry. So we also implement some pilot CIM and BIM application for the BS theory. For example, we can use the BSS to do the lightweight reconstruction, which converts the large-scale point clouds and photogrammetry data into very compact mesh models for the following analysis. And then we could also use the BSS to discover and group some building patterns. And based on the patterns we identify, we can use these patterns to transfer them for generative design to design the buildings consistent with the surrounding styles and some functions. So we believe the BSS could serve as the fundamental geometric and pattern representation to drive some and open some new avenues for the BIM and CIM application. Thank you, that's all.